Hello friends, now here I am with the short video number 6 of the subject Power Electronics, which is offered in 4th semester Electrical Engineering of Gujarat Technological University. This short video is on quick review of IGBT. The IGBT is the combination of MOSFET and BJT. It combines features of IGBT and MOSFET. You can see the MOSFET plus BJT is equal to IGBT. IGBT stands for insulated gate bipolar transistor. Insulated gate is there in MOSFET also, but this is, we can say, the feature of MOSFET and BJT are combined, and that's why it is insulated gate bipolar transistor. IGBTs are suitable for high voltage, high current applications. So compared to MOSFET, BJT, the power rating of IGBT is very, very good. These are the features of BJT. So BJT is a bipolar device, while MOSFET is unipolar. BJT is a low input impedance, but MOSFET is high input impedance. So that's a good feature of MOSFET. High switching losses in BJT, but lower conduction losses, that's a good feature. While lower switching losses is bad, but lower switching losses is a good feature of MOSFET, but high switch on and conduction losses. BJT is a current control device, which is not that good, while MOSFET is a voltage control device. So that's a good feature we would like to have. Then there is a negative temperature coefficient of resistance. So parallel operation is difficult in case of BJT, while the other way around for MOSFET. Secondary breakdown is there in BJT, which is not there. And as you can see, the BJT is available up to 1200 volt, 800 ampere, while MOSFET is not available in that high power range. So the insulated bipolar transistor IGBT combines best qualities of both BJT and MOSFET, as we have seen, the high input impedance of MOSFET and low in on-state power loss as in IGBT, right? So these are the other names. Now, this is the structure of the IGBT. So you can see that it is having a P plus substrate, which is injecting layer, and on which N plus buffer layer is there. It is not there in all the IGBTs, but it is there in PT IGBTs. Then there is N minus drift region, which is generally creating the reverse blocking voltage capacity. Then this emitter is having a P in that 2N plus regions are there. And then you have a SiO2 layer and a metal contact through which gate supply is given, right? So emitter is generally also known as source, collector also known as a drain, and gate is already there, the control terminal. So IGBT has a 4 alternate layers of PN with 3 terminals, drain, source, and gate, also known as collector, emitter, and gate. P plus substrate is the base on which everything is developed. N plus is buffer layer, not there in all the IGBTs. N minus is the drift region, and P plus is emitter or source with 2 N plus regions. Emitter to collector is a PNP like structure, right? Emitter to collector, that is source to drain, is a PNP like structure of a BJT. Now, how does this IGBT operate as a switch? So the VGS is the agency which is controlling the state of IGBT. If VGS is greater than a threshold voltage, then the switch is turned on. IGBT as a switch is turned on. And when VGS is less than VT, then it is turned off. Now, on application of VGS, the N channel induced by the field effect, forward bias is the base emitter junction, and similar to BJT, it gets turned on. Right? So once again, it is the field effect which is used to turn it on. N channel is induced by applying the VGS higher than the threshold voltage. So it is voltage operated, and the field effect is used over here, similar to MOSFET. Now, this is the circuit which is used when IGBT is used as a switch. Similar arrangement is there, and for characteristics also similar arrangement is there, right? So for you can say what different values of VGS, we would like to find out how much is the change in IC, right? So these are the characteristics. You can see drain current or collector current versus VCE, or V drain to source voltage you can call. So in the forward direction, the shape of output characteristics is similar to those of BJT, right? For a sufficiently large base current, we were having good collector current. Similarly, here sufficiently large gate voltage. So for a sufficiently large gate to source voltage, the drain current is, that means switch is on and we have a sufficiently large drain current. In place of base current, here VGS is the controlling, VGS is controlling the device. So that was the characteristics of an N-channel IGBT, and you can see in the reverse direction, similar to, you can say rather, a diode. It is having a blocking up to a breakdown voltage. So the applications of IGBTs are for DC and AC motor drives, UPS systems, power supplies, motor drives for solenoids, relays, and contactors. So in most of the medium power applications, IGBTs are used. Recent times, IGBT is available for high power rating also. So it is replacing the thyristors, about which we are going to learn in our subsequent videos. So this slide represents the comparison of MOSFET and IGBT. Both are three-terminal devices, both are having high input impedance, both are voltage controls, but rating of IGBT is available up to, you can say, 500 amperes to 100 volts. So at present, this data is changed, but this was the older data. Switching frequency, of course, MOSFET has larger switching frequency, and the best features of MOSFET and IGBTs are covered. MOSFET and BJTs are covered in an IGBT, right? So this is all about the insulated gate bipolar transistor. Once again, it is combination of MOSFET and BJT. It is turned on by gate supply, so it is voltage control. It is field effect, which is turning it on. It is in good features of BJT and MOSFET both. And in short, with medium switching frequency and for large power ratings compared to BJT and MOSFET, IGBT is always preferred, right? So that's all from my side in this video of IGBT. Once again, I'm repeating the same. This is for a quick review about IGBT. For detailed understanding, one has to go through good reference books, textbooks, right? So hope you will enjoy this video, and we'll continue with the next session with the SCR or thyristor family. Right? That's all from my side. Thank you.